Mangroves are unique for several reasons. They are highly productive, creating a lot of organic matter like leaves. This organic matter is difficult to decompose, a property called recalcitrance. Also, mangroves grow in consistently wet, oxygen-poor, or anoxic environments. When mangroves absorb carbon dioxide through photosynthesis, they store it in their biomass, such as leaves, branches, or roots. As they shed and regrow this biomass, the dead organic matter, which is hard to decompose, gets trapped in the waterlogged, low-oxygen soil. This prevents decomposition, keeping the carbon stored in the soil for hundreds or thousands of years. Today, we are spending the day with the mangrove man himself, Nicolas Moity, to see how he measures carbon and population of different species in the mangroves. To better understand the biodiversity of mangroves, Nicolas does fish transects. These are essentially underwater surveys. He would swim along a path, counting fish and recording the species. This gives us a general idea of fish populations and types in the area.
So today, we're going to the mangrove forest with Nicolas Moity so we can learn more about his research and exactly what he does to preserve the mangroves here on the Galápagos Islands.
There are many methods to measuring carbon. However, today we'll just be measuring carbon in the soil and the biomass of the mangroves in Tortuga Bay.
So we are measuring the soil carbon pool component right now. And from our center point, we are doing a 6-meter transect, and each half meter we are measuring soil depth. So what you would do is you are at your each half meter, you enter your pole down to the deepest part where you can go. So in this case, it's the whole pole, so we know it's more than 1.5 meter. So once we do that, we would take out our pole, measure this. We know it's 1.5, so we don't need to measure it right now. And we would write down the information so that later we can reconstruct the structure of the soil of this mangrove patch. So now we do the
sample.
Yeah.
Yeah.
Usually you do this after because you know where your soil is deeper. So we know the 3 points where I could very deep. So your coring device has a hole, like a half hole, and a point. So this one is serrated because usually mangroves at least in the Galápagos, have many roots. So you have to actually go through them and turn this to cut them. And you enter this into the soil and you add to this depth and you take this sample, and then you go deeper and you take the next. So that's why I was saying it's always 30 centimeters by 30 centimeters. So let's say this one was deep, right? So we can do this one. So you clean up the area. Let's say you have a leaf. This doesn't count in your, because you remember this was the pool of the leaf litter.
Yeah.
So we don't want that in the soil pool. So you actually put all your weight like before, the same thing. And you go down and you see it's very hard. There we have our first sample. You have to stop there. You can see the roots there?
Yeah.
All of these are roots. So actually mangrove roots make up mangrove soil. That's why the mangrove soil is so rich in carbon, organic carbon. So I have this device, proudly made by Nico. You see, this is the surface, this is the bottom. Because what you do is you put this inside here, so you have a scale, and you take a picture with your notes. And from here, what I would do is I take 5 centimeter pieces. So from here to here is 5 centimeters, right? So I cut here, take my little thing, and take. So you see it's a mixture of roots and sand and shells. So you would label this. So this would be core 1. Usually you do 3 cores per site.
After we were done collecting the samples in the field, we made our way back to the Charles Darwin Research Station to continue the process.
When we come back from the field, we take our soil samples and we need to dry them. So we take each one, we make sure it remains open so it can dry and the water can evaporate. Then we go with that to the dryer and we leave it for 3 days at 70 degrees. When it's completely dry, we come back to the lab and we have to weight each soil sample. We take a note of all the weights and then the sample can go to analysis in a special machine.
Stay tuned for the third video in this series to see how this work contributes to the success of mangrove forests around the Galápagos and how the rest of the world can learn to sustain their mangroves by studying the conservation practices and ecological management techniques implemented here in the Galápagos Islands.